In today's video, we're going to be talking about Clinvar and 23andme. We're going to analyze pathological variants. And before we begin, I just want to mention that I'm not a genetics expert. This is really just a quick demo for BioBricks, showing how quick and easy it is to combine public health data with your own private data if you want to. And if you're actually looking at this kind of report, you should do your own research and you should talk to a genetics expert before acting on anything like this. Okay, let's jump into the demo. Today we're going to look at 23andme. 23andme used to give you a variant report if you got your sequencing done with them. They might still do that. And we're going to show how you could combine that data with Clinvar really, really quickly. So if you look at this old variant report, you know, the new ones might look different, but they used to give you this tab delimited file with an RSID, so that's an identifier, chromosome position, and genotype. We got this file. We might be tempted to start Googling some of these RSIDs and seeing if we can find them and see if we can learn anything about ourselves after seeing what our SNPs are. How our genome differs from the reference genome. But you'd be sort of hard pressed to do that for all your SNPs because at least in this example file, we've got 610,000 of those. So we're going to need a slightly better way to get that data. And the first thing we might ask is, where can we find that data? So the title of this video kind of gives it away. But the eventual idea for BioBricks, and there's a demo working right now at biobricks.ddns.net, is to be able to use natural language to talk to the data. So you might ask, where can I find clinical information about genetic variants with the column RSID? Looking for someone to join my variant table with. And sure enough, BioBricks, the demo today, tells you, okay, Clinvar is a pretty good place to look for that information. It has a table called var citations. And if we zoom this out a little bit, we can see, there's an RS there. It looks like it's incorrectly formatted as a double rather than a number. So that would give us something to join against. And it gives us a good database to look at. We call it a brick to look at. Okay, so how would we write some code to go ahead and do this? Well, let's go ahead and make a new file. So we'll just touch a Clinvar 23andme.r, and this Clinvar 23andme, and we're going to need BioBricks for this. So we'll do pip install. I actually already have it, but just make sure I have the most recent one. Okay, so we have BioBricks coming in now. Looks like I didn't have the most recent one. So good thing I ran an update. Okay, so now we have BioBricks, and now we want to configure BioBricks. So we're going to overwrite my existing configuration. We're not going to use that library. We're going to use a new one. We'll call it temps BioBricks 2. So basically, this is the path where BioBricks is going to store data on your machine. And I'm going to use the default token, which is a free token, but you can register at biobricks.ai to get a permanent token. Okay, so now we have BioBricks, and we also need to get BioBricks in R. I already have that, but you could install it just with remotes, and it would just be biobricks-ai, biobricks-r, and go ahead and work for me. So the R client for BioBricks is just a thin wrapper around a Python client. Nothing too interesting to see there. And I'm going to skip the updates. So not update anything. Give that just a second to run. All right, so we have BioBricks and R now. All right, so to analyze this data, let's just pull in two packages. We're going to pull in BioBricks, and we're going to pull in tidyverse. Okay, and just see if we have both those things. We do. Great. So the first thing we need to do is actually just load Clinvar. We identified that as the brick that we want to use. So I'm going to make sure I have it installed first. I don't have it installed because I just set my BioBricks library to a new directory. So it's installing it now. And now it's pulling the database and get the database relatively quickly. There are about 10 Parquet files in the database. So probably about 10 tables. Parquet files, sometimes there's multiple files for one table. But yeah, so we just installed Clinvar. We don't need this bottom terminal anymore. And we can load it with this line. Let's give it a second. Okay, so we have all of the tables coming in. And I think when we were looking at biobricks.ddns.net, we saw var citations as the table that it was suggesting. I'm actually going to look at variant summary, see what's in there. That seems like it's going to have some summary data about clinical variants. And then we have an interesting variable here. First, we have gene names, allele IDs, HGNC ID. We need something that looks like RSID. And that looks like it right there. So RS, DBS, and P. So that should be a good variable for us to join on here. So let's go ahead and pull that variant summary. We'll call it var sum. Let's just keep using the name CV, actually. So CV $var variant summary. We'll collect that. And yeah, so not a huge table here. Didn't take too long to load it into RAM. At the moment, scan over some of the other IDs in here. So clinical significance looks interesting to me. The clinsig simple is like a enumeration of clinical significance. And then looking for something that's like, tells me a little bit about what this does. Look around here a little bit. There we go. Phenotype IDs, that looks promising, or a phenotype list. That's probably even better. IDs are probably sort of identifier, but if we want something that we can look at and maybe understand as humans, clinical list looks pretty good. So that gave us 3 things to look at. So right now our CV table, this is our CV table. You can see all that information in it. And we identified the RSID. So we're going to call that, or that was called RS, DB, S&P. And phenotype list and clinical significance. Those look pretty interesting. So let's see what our table looks like now. Okay, that looks pretty good. So we've got this RSID. These look like numbers. We've got this phenotype list that looks like something I can read. Those look like diseases or phenotypes. And then we've got clinical significance. So pathologic is the thing here. And a phenotype list tells me that this is going to be some sort of list. So if I just take a look at the phenotype list here and ask, what are the unique values? Looks like there are a lot of them. And yeah, sure enough, there's a delimiter in there. So this is a list. It's providing multiple phenotypes and delimiting them by this vertical bar. So let's rename things a little bit. So this is going to work better with our data from 23andme. So let's take a look at that data again. We had RSID, chromosome position, phenotype. Let's go ahead and load that data so we can make sure we're loading things correctly. So we'll call it andme, and we'll use reader, tab delimited file. Was it 20? It's 23andme 60. Okay, and the comment was hash sign, and the column names are RSID, ID, character, and position. Okay, pull that in, see if that works. Looks like it did. And yeah, so we've got RSID, ID, chromosome, and position. Yeah, so that's pretty good. A little bit OCD about having there. So we want this RS up here to match this RSID down here. So we're just going to say RSID is equal to the first column. And let's make the other columns a little bit shorter. We'll say phenotype list is equal to pheno, and clinical significance, we'll call that significance, signi. And so, yeah, so now we've got RSID in both of our tables, and we have a shorter version of phenotype and significance. All right. So now if we want to take this table and start figuring out, what phenotypes might be relevant to me, given that I have these specific variants, I can just join these tables together. But before I do that, I'm going to have to modify the variant summary table a little bit, just because it seems like it has multiple phenotypes in each row. So we're going to go ahead and split that pheno column by that delimiter that it has, and then we're going to unnest it. So I think that should work. Then we're going to do the same thing for the significance. If I just slide, you can see I took the variance file. I've run this line, the variance summary table, varsum, and I changed the phenotype column. I just pulled the delimiter out and made a list out of it, and then I unnested that list. So now we should just have one phenotype per row and one clinical significance per row. And so if I run, got to run this line too. Give that a second. So yeah, there we go. So we can, once again, let's just count different kinds of significance. Yeah, so that looks pretty good. Print equals. Yeah, so I don't see, oh, well, I mean, those semicolons aren't great. Maybe for significance, it uses the semicolon rather than vertical bar. So let's just go ahead and put that in there. There we go. Looks like we could clean this up a little bit more even, maybe by like trimming these strings. But this doesn't look too bad. The pathogenic, looks like there's a bunch of pathogenic variants in here. Maybe those are the ones I'm interested in. So the last thing I'll do here is just say, you know, let's take CV and filter it and say that the signi equal to pathogenic. Yeah. Okay, so now we've got a bunch of pathogenic variants, and we want to see which of those we actually have in our 23andme report. So we're going to go ahead and join these. So we'll call this report rep. Let's call it results res. And we'll say enme. So we'll just filter down the Clinvar table, and we'll filter it and say RSID has to be in the enme RSID. So let's just check those again. So in the Clinvar table, we have these RSIDs that are numeric, and the in the 23andme report, we have these strings that all have this RS prefix. So let's go ahead and get rid of that RS prefix. And yeah, we'll just say mutate RSID equals s.numeric, and we'll just remove RS from that column. And it looks like we have a few NAs coming in there, but yeah, it looks like that did what we wanted. So, you know, we'd have to look pretty carefully about what these tables really mean, but it looks like we should be able to join these tables now and maybe build a report out of the results. So let's go ahead and do that. Sorry, not join, but just filter down the Clinvar table to the variants that are in my 23andme report here. And this isn't my report, it's just report. Okay, so there's our result. Yeah, so filtered it down. And sure enough, we've got about 10,000 examples here in the join. So there are 10,000 potentially pathogenic variants in this report. And I might want to know, you know, which of these are the most common variants. So I might just say, you know, count, or what are the most common phenotypes? Sort that, and not provided is pretty common. Lynch syndrome, I got a bunch of those in there. Hereditary cancer predisposing syndrome. So that's kind of interesting. You know, one thing we might think right off the bat is just that some phenotypes might have more variants reported for them than other phenotypes. So maybe what we actually want to know is if we group by, think about this for a second. Okay, I have an idea. So what we'll do is we'll take our Clinvar data again, we'll load it all up, and rather than filtering, we'll say let's say has variant equals RSID in the 23andme table. So we just pulled the Clinvar database again, and let's run that result again. Variant and oh, there we go. So now we have just a flag saying whether or not the variant in the given row is in our 23andme file. And what this will let us do is take our result and say, let's group by phenotype and summarize by my count is equal to some has variant. That'll just count the number of variants that my report has, or this report has. And yeah, so now we have my count and the total count. I'll just call that count. And if we take a look at res now, we can see both of those showing up. So the last thing we want to say is enrichment. So we'll say enrichment is equal to my count divided by the total count. And we'll go ahead and arrange that by descending enrichment. And just because like if we have one variant and it only has one reported variant and Clinvar, maybe that's like a phenotype that doesn't make a lot of sense. I mean, let's go ahead and see what happens if we. Yeah, so there are a bunch of things at the top where it's just like, I'd have these two variants and they're both reported in Clinvar. So I have a 100% enrichment, but there's just not very many variants reported in Clinvar. So, these sort of like rare phenotypes, maybe they're not very interesting to me. So let's just filter this down and say, I want to see if there are any phenotypes that have like hundreds of variants and if there are any of them that I actually have a lot of those variants. So run this again and take a look at the result. And there we go. Now we've got a few interesting things that we might want to Google about. Pseudoxanthoma elasticum. Take a look at that. Maybe it's interesting. Elastic fibers primarily affecting the skin, retina, and cardiovascular system. That's interesting. And it seems like for whatever reason, those are showing up a lot in this variant report. And there's nothing saying that I've done this perfectly. I'm not an expert in Clinvar. The point of this was really just to show that in less than 20 minutes, you could pull a variant report and start comparing it to Clinvar data. This is a lot faster than Googling your RSIDs one by one, or even like figuring out how to download the Clinvar data and or using various packages or APIs for accessing the Clinvar data. So with BioBricks, we can make it really easy to get data quickly, and if you can get the data fast, you can do all sorts of analyses that maybe you wouldn't have done otherwise, just because it would take so much time to get the data. That barrier is too big to do the analysis. But if we can do it in 20 minutes, why not give it a try? So that's it for today's video. Hopefully I have another one tomorrow. Thanks for watching.